In section 41, we're going to learn one more approximation method. So we've learned right-hand endpoints, left-hand endpoints, midpoint rule. Now we're going to learn something called the trapezoidal rule. So I have a little sketch of the trapezoidal rule here, which I think should make sense to you. So basically, if you find, f of a, and then f of whatever this is, and then you connect their two heights with a straight line, you end up getting a trapezoid that's on its side. Okay, and we can find the area of a trapezoid, right? We can find the area of that using the formula A is equal to 1/2 H times B1 plus B2. So basically what we're going to do is we're going to take, trapezoid number 1, number 2, number 3, and we're going to add all of them together to get an approximation for the area under the curve. This is actually a very good approximation method. In a way, it's kind of better than the rectangles because it makes it even closer than the rectangles did. Rectangles, you would be cutting off this little triangular portion. So with trapezoids, it's kind of nice. All right, so there is a complicated formula for the trapezoidal rule, but I urge you not to memorize this formula because most of the ones that are on the AP test do not have what we call a common width. Okay, so the height of each of these trapezoids is not going to be the same on the AP test, and I'll explain what I mean by that later on in this section. All right, so number 1. So let's find the trapezoidal rule with approximation n equals 4. So again, this means 4 rectangles, 4 trapezoids. But for the integral from 0 to 1 of 3x squared. All right, so if I graph my curve, you know that 3x squared is a parabola, and we're finding the area from 0 to 1. Okay, so we're finding this area that's under the curve. And we're breaking it into 4 subintervals. Okay, so I'm going to have 1/2, and then here and here. Okay. Okay, and I'm going to go ahead and find the heights at each of those numbers. Okay, so you could use a table, and you could very quickly find the heights. So if you did like a little t-table, you would get that the height at 0.25 is 0.1875. So that's just plugging into the function 3x squared. The height at 0.5 is 0.75. The height at 0.75 is 1.6875. And the height at 1 is 3. And then, of course, the height at 0 is 0. And we're going to connect these points to create trapezoids. Okay, so I have, it's not really a trapezoid for this first one. If you notice, that one actually ends up being a triangle because the first height was 0. And then we have a trapezoid here. I'll use different colors so you can see all of them. And then we have a trapezoid here. And then finally, we have a trapezoid here. Okay, so we have 4 trapezoids. So we call this T sub 4, kind of like we did with the midpoint rule. So if I'm finding the height or the area of the first trapezoid, even though I know it's a triangle, we're going to do 1/2 H, which H is going to be this distance here, which is 0.25, times B1 plus B2. So in this case, B1 is 0 and B2 is 0.1875. Okay, and you could leave off the 0, and you would see it's just the area of a triangle, right? 1/2 base times height. All right, but I'm going to leave the 0 in there so you guys can see where the trapezoid formula comes from. All right, so the next one, I'm going to have 1/2. Again, the height of the trapezoid, because it's on its side, right? So the height is here, which is really right there. And that height is 0.25. And then the B1 and B2, well, now the B1 is here, 0.1875, and the B2 is 0.75. Okay, do you guys see those here and here? All right, so I have 0.25, and then B1 plus B2. All right, and then I do it again. So I have 1/2 height, so again, 0.225, B1 plus B2. So now I have 0.75 plus 1.6875. And then the last one, the black trapezoid, is going to be 1/2 height. So again, 0.25, got my decimal point very well. All right, and then my B1, 1.6875, and B2, which is 3. So what happens as you're doing this is you could pull out the common factor of 1/2. They all have a 1/2 in common. And they actually all have this common width in common. And that's what I was saying. A lot of times on the AP test, they're not going to use a common width. So that's why I don't really want you to memorize the formula. I just wanted you to know why the formula works the way it works. So what you can end up pulling out is the 1/2 and then what we're calling H, so 0.25. So each of those trapezoids have, a height, air quotes, of 0.25. I know it's like on its side, but do you guys understand that? All right, and then when we do that, we get our 0, and then we have 1.875, but then we have it again, right? So we have 2 of those 1.8, or not 1.875, 0.1875. And then we have 2 of the 0.75s, right? Because it's acting as like the B1 for one of the trapezoids, but then the B2 for the other trapezoid, right? And then we have 2 of these 1.675s. 875. And then lastly, we only have 1 of the 3s, right? Which makes sense because it's not, this 3 isn't in, it's only in 1 trapezoid. It's not in 2. Whereas, like this distance right here, that was a distance, a B1 and a B2. It was in 2 trapezoids. Does that make sense? And that's exactly where this trapezoid formula comes from. So it's saying delta x, which is the height, and then the 2 is 1/2, right? So we have 1/2 times the height, and then we have the first endpoint, like the first height, f of x0, and then we have 2 of all the other ones, except for the last one, which is f of x of n. Okay, so that's where that formula comes from. All right, and then we can compute this. So if you find this value, you'll end up getting 1.03125. So we'll say, if we round to 3 decimal points, 1.031. Okay? So the question is, how accurate is your approximation? So I told you the actual area, it has to do with antiderivatives, right? If I'm doing the integral from 0 to 1 of 3x squared dx, when I integrate, I get x cubed. When I go from 0 to 1, so I got 1 cubed minus 0 cubed, which is just 1 cubed, which is 1. Okay, so the actual area is 1, and we were pretty darn close with 1.031. We were just a little bit more than what you would think it would be. All right. Next up. All right, so number 2 says the table gives the measurements in feet of the width of a plot of land at 10-foot intervals. Estimate the area with n equals 6 using a trapezoidal rule. So we're going to use t sub 6 and the midpoint rule. So we're also going to find n sub 6. Okay, and this is really kind of tricky because if you look, if we're starting with 0, 10, 20, and so on, going all the way to 120, we actually have 12 basically rectangles there. So I could sketch this out for you. I'm not going to waste your time with this one, but I'll do it for the next one so you can see what I mean by sketching it out. And sometimes sketches help students. So a lot of you are very, very visual. You want to see the picture. So if you want to see it, it's fine. You can sketch out these different numbers. But if we have n equals 6, basically what we're going to do is we're going to have to take, since we have 0 to 120, that's a distance of 120. We want to take size 20 for our interval. So we're going to have like 0 to 20, but then also 20 to 40, 40 to 60, 60 to 80, 80 to 100, and 100 to 120. Okay, so we're skipping all of those ones in the middle. They don't actually really even matter. They will for the midpoint rule, though. Okay, so for the trapezoidal rule, I'll do a little rough sketch of the first few so you can see. We have 0, 56. We have 20, 58. We have 40, 58. We have 60, 62, and so on. Okay. So what we're doing is we're creating these trapezoids where we're connecting the 2 heights, and we're creating all of these different trapezoids, okay? So the formula, we're allowed to use the formula for this one because they're all a common width, meaning the height of the trapezoids, I know they're on their sides, but the height is all 20. Okay, so our formula says that we would have the 1/2, and then we would have 20 for all of them. And then for that first trapezoid, we'd have B1 plus B2. Well, that would be the 56 and the 58, right? And then the second trapezoid, we're going to have B1 plus B2, right? Meaning B1 and B2. All right, and then the next trapezoid, I'm going to definitely need more room, is going to be B1 plus B2. And then B1 plus B2, right? B1, B2, B1 plus B2, and then the last one, 40 plus 22. All right, so you can see where that little, the 2 times f of whatever is coming from in the formula. It's because, you know, like, for instance, we had 2 62s, we had 2 52s, and so on. Just a second. All right. All right, so if we find all of that, you can easily put that into your calculator. The trapezoidal rule, that approximation ends up being 6,180, and our units then would be square feet because it's an area. So, you know, this distance is in feet and this distance is in feet. So feet by feet create something that is square feet, right? All right, so same thing for m sub 6. So the midpoint rule was 6. Hang on. Okay, so the midpoint rule. So when we're doing the midpoint rule, again, we have a distance of 120. So our rectangles need to be, you know, if we're going to have 6 of them, they need to be 20 units long. But if you remember from the midpoint rule, we use the points that are in the middle, right? So what we're going to use for the midpoint rule are actually these points right here. Okay, and we're going to ignore everything else. So basically, if I was doing like a little rough sketch of the first view, so you can see it, we'd have 0 and we'd have, well, let me use the other picture that I have actually. We have 0 and 56, and we have 10 and 54. So when we create our rectangle, we use the one that's in the middle, okay? And then we had 58, 62, so we would use the one that's in the middle, okay? So that's how the midpoint rule works. So for our midpoint rule, the width of each one is 20. So each of these is going to have a width of 20, and then the first height is 54. And then we have a width of 20 and 62, a width of 20, 58, a width of 20, 56, a width of 20, 48, a width of 20, and 32. So you could easily pull out the 20, right? Instead of writing it all out like that, and your final answer is going to be very, very close to the trapezoidal rule. You get 6,200 square feet. So unless your numbers are kind of all over the place, those numbers will be very close to each other. They should be. All right, and then the next one, and the last one, kind of shows you exactly what the AP test usually does. Okay, so usually we don't have a common width on the AP test. So on these, like I said, if you are someone that needs to sketch things out, go ahead and sketch it out. It takes like, you know, an extra minute. It's not really going to be terribly time consuming to do this. Okay, so I'm just kind of sketching some things out, sketching out their various heights. And you can see that some of them are closer than others. Okay, so we have that. So if you need to connect those points, kind of connecting the dots, right? Then you get your various trapezoids. Okay. So you don't really need to do that. Some of you are going to be great doing this without sketching it. Basically, you always want to find the widths. Okay. So the first width is 5. The next one is 7. The next one is 2. And then the last one is 6. And those are the various heights of the trapezoids, right? Remember the heights because the trapezoid is on its side. So our trapezoidal rule with n equals 4 is going to be, we're going to have 1/2, and our first height is 5, and then we have our b1 plus b2. Well, those end up just being these two numbers here. So we're going to have 25 plus 50, which you can see 25 and 50, right? And then our next one, we have 1/2, and now its height is 7, and it's going to be the 50 and the 30, which you can see on the picture. And then I'm going to have 1/2 times 2, and then I'm going to have 30 plus 22, and then I'm going to have 1/2 times 6, and I'm going to have 22 plus 10. Okay, and I went ahead and found that. Again, we're in feet. So when we come up with this area, we end up getting 615.5 square feet. All right, so that's an example of what would be on your AP test. And this does pop up often, not just on the multiple choice, but also on the free response. They'll ask you a lot of trapezoidal rule questions on the free response. So it's not really a difficult topic. Hopefully it's a pretty easy one for your last lesson for J term. But if you get stuck, make sure you ask me for help.